Okay, we're looking at 6.6, which is scale drawings. And if you've ever seen house plans or anything like that, what you've seen is a scale drawing. A scale drawing is a drawing that is similar to the object it represents. So a house plan obviously represents a much larger house, um, but the house plan is just a drawing that is similar to the original, okay, or the real thing. Meaning it's the same size in every way, but it's not necessarily the same, the same shape, not necessarily the same size. Okay, a scale model would be a three-dimensional model that is similar to the object you represent. So if you're doing the Alamo and you did it to scale, meaning you have everything the same shape, it would just be a smaller size. That would be a scale model. The scale of a scale drawing or scale model gives the relationship between the drawing our model's dimensions and the actual dimensions. So sometimes on a house plan, you may see something that's one to I'm sorry. Let's do this. Sometimes you'll see 1/4 of an inch equals 1 foot. So what they're saying is on the plan, if you measure with your ruler 1/4 of an inch, and on the real thing, that's going to be a foot. Okay, you may have something that looks like 1 to 75 or 1 to 50. Well, that means whatever you measure on the drawing, one of those is going to equal to 75 of those on the real thing. So 1 foot would equal 75 feet, 1 inch would equal 75 inches. Okay, so sometimes the scale actually has units associated with it. Sometimes the scale does not, and we're going to look at both today. Let's look at this scale on the map. That we have a scale of 1 centimeter to 200 meters. Now this scale is a ratio. Okay, 1 centimeter, 200 meters. Okay, so on a map, two objects are 4 centimeters apart. What is the actual distance? Well, to solve this, we probably could do this in our head, but to set it up, we could set up a proportion like we did the last section. Okay, I've got centimeters on top, and I'm given centimeters, so I have to match centimeters to centimeters. And I'm looking for the actual distance. Well, the actual distance is going to have to be in meters. Okay, if I'm given centimeters, the actual distance in meters. Okay, then I could cross multiply. I've got 1x equals 4 times 2, which is 800. Right? Okay, on this next problem, on the same map, an object has a length and a width of 1.1 centimeters. Find the actual dimensions. So 1.1 centimeters, again, somehow I'm back on yellow, black here. 1 centimeter to 200 meters. And I'm given 1.1 centimeter. Well, that has to match up with centimeters. Okay, and I'm looking for x. Well, I'm going to cross multiply. Well, that's just 1x, right? And 1.1 times 200 is 220. So I've got 220 meters by 220 meters, right? Because I'm given a length and a width of 1.1. Sorry, that's 220. Anyway, so the scale we're given is a ratio, and we're going to use it in a proportion to find the missing item, whatever that may be. So look at this word problem. This is all fluff, but suppose a floral carpet is to be 40 meters wide. A designer creates a scale drawing of the carpet that is 20 centimeters wide. Find the drawing scale. Well, anytime you see a scale on a drawing, the top number represents the drawing. So if I see like 1 to 8, the first number, or if I may say it like this, the first number, the top number, always represents the drawing or the model. The second number represents the real thing. Okay, so if the drawing in a drawing the carpet is 20 centimeters wide, well, that's the drawing that goes on top, 20 centimeters. Well, the real thing is 40 meters. Well, the real thing is the bottom number. Okay, so 20 centimeters to 40 meters, I can reduce this, right? So that's really 1 centimeter is going to equal 2 meters. And this is my scale for the drawing. Okay, so what I did is I found an actual length on the drawing and an actual length that corresponded to on the real thing, and I just made a ratio and reduced it. So this must be the scale. And remember, thing to remember, on the scale, the top number represents the drawing or the model, that the bottom number represents the real thing. Let's look at the next page. Okay, now we can write scales without units. Okay, remember I said sometimes you see scales with units, like you may see 1 to 8, or you may see 1 inch to 8 yards, or something like this. You see scales like this, and you see scales like this. We're going to take scales like this and write them into scales like this, and it's a very simple way of doing it. If I have the same units, like if I have inches here and inches here, then I can write the scale without having any units at all. So all I have to do this is to change this to this. So I want to change yards to inches. Okay, well, how do I do that? Well, I need to know how many inches in a yard. Okay, so if I'm changing yards to inches, I multiply by 36. So 28 times 36, that gives me 1008. So I can rewrite the scale 1 to 1008. Look here. Okay, I've got 1 inch to 4 feet. I want to change this to inches. Well, I'll multiply by 12. That gives me 1 to 48. And this is the scale without units. The good thing about the scale without units is if I measure in meters, my answer's in meters. If I measure in inches, my answer's in inches. If I measure in feet, my answer's in feet. So it really works well without units. Okay, let's change this to centimeters. Well, I just have to multiply by 100 because there's 100 centimeters in a meter. So that gives me 1 to 1200. Okay, here there are 1,000 millimeters in a meter. Multiply that, I get 1 to 2,000. Very straightforward. Okay, next. The model of a space shuttle has a scale of 1 to 52. That's a scale without units. Okay, and so your scale is a ratio. Let me rewrite that to where it looks better. Okay, the space shuttle has a wingspan of 78 feet. Find the model's wingspan. Well, this is x, right? The model's wingspan. Now, remember I said the top number represents the model or the drawing, the bottom number represents the real thing. If I'm finding the model's wingspan, well, x has to match up with the model's number here, which is here. 78 feet is the real wingspan, so that has to go here. Now I just cross multiply. 52x equals 78. I'm going to divide 78 by 52, and I'm going to get 1.5. X is equal to 1.5, and because I started in feet, my answer's in feet, because I've got, this is without units. Okay, the length, again, we're talking about the space shuttle. I'm going to use the same ratio, 1 to 52. The length of the space shuttle is 122 feet. Okay, that matches with the 52 because it's the real thing. It goes on bottom. I'm looking for the scale model, the length of the scale model. Well, that's x. Cross multiply, 52x equals 122. I'm going to do it to the nearest tenth. So 122 divided by 52, and that's going to be 2 point, we're going to stop at 3 right there, 2.3 feet. Okay, again, we're just using proportions like we've done before to solve for x. Okay, here a map has a scale of 1 inch to 40 miles. Use the given map distance to find the actual distance. So I'm going to use this 1 inch to 40 miles. Okay, make a proportion. Well, where does 5 inches go? Well, inches matches with inches. And I'm finding actual distance, so that's x. Okay, so 1 times x is 1x. All of these I should get 1x when I multiply. So 5 times 40 would be 200 miles. Okay, let's look at this one. Use the same scale or the same ratio, 1 inch 40 miles equals, well, I'm looking for the map distance or the actual distance, which is on the bottom. The map distance is 12 inches. Inches matches with inches on top, okay? So this must be miles down here. 1x is equal to 12 times 40, which is 480 miles. Here, again, use the same ratio, 1 inch to 40 miles. Okay, 32 inches goes on top with this. I'm looking for x. So I've got 32 times 40. That gives me 1280. So x is equal, I'm sorry, 1280 miles. Here, 2 feet. Well, I'm not dealing with feet, I'm dealing with inches. Okay, so I have to put it in inches. It gives me 24 inches. I want to know how many miles that is. Well, if 12 inches is 480 miles, then 24 inches will be double that, which is 960. Okay, and that's using the the ratio that they've given us, the scale, and matching inches to inches on top and finding miles on the bottom. Now, if we were given miles, then that would go on bottom and X would go on top. So say here we were given 5 miles, we need to see how many inches that would be. 5 would go on bottom, X would go on top. You understand that? So we're matching unit to unit when we're doing this. And that concludes today's lesson.